Okay, let's get into it. Fine. Let's start. Number 10. The Chelyabinsk Meteor. It was just after 9 in the morning on February 15th, 2013, and the people of Chelyabinsk were doing the most ordinary things in the world. Driving to work, scraping ice off windshields, sitting in classrooms with the heating on against the Russian winter. And then the sky turned white, brighter than the sun. For a few seconds, a second sun hung over the city, trailing a thick rope of smoke across the cold blue morning. People stopped. They pointed. They walked to their windows to get a better look. And that, it turns out, was the dangerous part. What they were watching was a rock about 17 to 20 meters across. A small asteroid, roughly the size of a 6-story building, slamming into the upper atmosphere at tens of thousands of miles per hour. When it exploded, it released energy equivalent to about 500 kilotons of TNT. That's around 30 times the energy of the bomb dropped on Hiroshima. All of it, dumped into the air above a city of more than 1 million people. Here's the thing about an explosion like that. The light reaches you instantly. The sound and the shockwave do not. So for a long, strange moment, the people of Chelyabinsk saw a brilliant flash and felt nothing. They crowded to the glass. And then the blast wave arrived, and the windows came in. Nearly 1,500 people were hurt badly enough to seek medical treatment. Almost none of them were hurt by the rock itself. They were cut by their own windows, by ordinary panes of glass turned into shrapnel, by something that exploded miles above their heads. We have footage of this, more footage than almost any natural event in history, because half the cars in Russia have dashboard cameras. You've probably seen it. The white streak, the trail of smoke, somebody swearing quietly in Russian. But here's the detail that should keep you up at night. We never saw it coming. Not because we weren't looking, but because it approached from the direction of the sun. Our telescopes were pointed into glare. The object was completely invisible, hiding in the one blind spot we can't cover, right up until the moment it announced itself by detonating over a major city. It was the largest natural object to hit our atmosphere since 1908. And it gave us no warning at all. It just arrived on an ordinary Tuesday morning and turned the sky white. Number 9. Asteroid 2019. Okay. 6 years after Chelyabinsk, on the night of July 25th, 2019, a far bigger rock passed by Earth, and almost nobody knew it was there until the day before. It's called 2019 OK, which is an unfortunately casual name for something this serious. It was somewhere between 57 and 130 meters across. Call it the size of a football stadium. That's not a Chelyabinsk-grade pebble. That's a city killer. If it had come down over land, the blast could have flattened an area tens of kilometers across, with energy easily exceeding 30 Hiroshima bombs. It passed us at about 72,000 kilometers. That sounds like a lot. It isn't. That's less than a fifth of the distance to the moon. In cosmic terms, it shaved past our cheek, and we found it roughly 24 hours beforehand. A telescope survey in Brazil spotted it first, this faint moving dot, and as astronomers scrambled to work out its path, they realized it was already almost on top of us. One of the largest objects to pass this close in about a century, and we had a single day of warning. There was nothing anyone could have done. If the numbers had come out differently, if that orbit had intersected ours instead of missing, the first most of us would have heard about it would have been the explosion. There's a NASA email from around that time, written as the realization sank in, and the line that everyone remembers is blunt and a little rattled. This one, it said, did sneak up on us. That's the quiet horror of it. Not that it hit. It didn't. But that's something the size of a stadium can still cross most of the solar system and arrive at our doorstep while we're looking the other way. The sky is not as well guarded as you'd like to believe. Number 8. The Great Daylight Fireball. On August 10th, 1972, Tourists at Grand Teton National Park looked up into a clear afternoon sky and watched a fireball cross the heavens in broad daylight. This basically never happens. Meteors are creatures of the dark. To see one blaze in full daylight, it has to be big, and it has to be close. This one was both. It was a meteoroid about the size of a small truck, and it didn't fall toward the ground. It came in at a shallow angle, a grazing angle, and skimmed through the very top of our atmosphere like a flat stone skipping across a calm lake. At its closest, it passed within about 57 kilometers of the surface. It tore across the daytime sky from Utah, up through the western United States, and back out over Alberta, Canada. People filmed it. Military sensors tracked it, and then it left. That's the part that gets me. It left. It dipped one toe into our atmosphere, glowed white-hot for several seconds in front of thousands of witnesses, and bounced back out into space. The encounter slowed it down by a fraction of a kilometer per second and bent its orbit, and off it went, carrying the scorch marks of its visit to Earth. But here's the thing. If it had come in just a little steeper, if the geometry had been slightly less forgiving, it would not have skipped. It would have plunged in, lost all its speed in the thick air, and detonated in an airburst with energy comparable to the bombs dropped on Hiroshima and Nagasaki combined. We didn't dodge it. It dodged us. It glanced off the planet and kept going. And the only reason we tell the story as a marvel instead of a catastrophe is the angle it happened to be traveling. A few degrees. That's the whole margin. Number 7. Apophis. Most of the disasters on this list already happened. This one hasn't yet, and we know, almost to the minute, when it's coming. On April 13th, 2029, a Friday the 13th, which is just the universe showing off, an asteroid named Apophis is going to pass closer to Earth than some of our own satellites. We're talking about a rock roughly 450 meters across at its longest, taller than the Empire State Building, bigger than 5 football fields laid end to end. It's named after the Egyptian god of chaos, and it earned the name. When Apophis was discovered, astronomers ran its orbit forward and got a result that made their blood run cold. For a while, it held the highest rating any asteroid has ever scored on our impact hazard scales. There was a genuine, calculated chance that this thing would hit us. For a few tense years, Apophis was the most dangerous object in the sky. Then we got more observations, refined the orbit, and breathed out. It will not hit us in 2029. It will not hit us for the foreseeable future. The calculations are solid now. But here's the thing. It's still going to come terrifyingly close. About 31,600 kilometers above the surface. That's 1/10 of the distance to the moon. That's inside the ring of geostationary satellites that carry our television and our weather data. From parts of Europe, Africa, and Asia, you'll be able to walk outside, look up, and watch it cross the night sky with your naked eyes. A point of light that is a 1/4-mile wide mountain, sliding past us in the dark. It will be the closest approach by an object this size that humanity has ever known about in advance. A dress rehearsal we didn't ask for. And all over the world, every telescope and radar dish we have will be pointed at it, watching, measuring, learning, because the next mountain that comes this close might not be so polite about missing. Number 6. The solar storm that almost killed Apollo. Not every disaster is a rock. Some of them come from the sun, 93 million miles away, and they don't need to touch the ground to be lethal. In early August 1972, the same month as that daylight fireball, oddly enough, the sun threw a tantrum. Between August 2nd and 11th, it unleashed some of the most violent solar flares of the entire space age. We're talking about the strongest classification we have, X-class flares, firing off one after another from a single, furious region on the sun's surface. The storm of charged particles that came screaming off the sun was monstrous. Now, here's why that particular storm is legendary at NASA, spoken about almost in a hush. It happened right in the middle of the Apollo program. The crew of Apollo 16 had splashed down safely back in April. The crew of Apollo 17 wouldn't launch until December, so in August of 1972, there were no humans in deep space. The radiation poured through empty orbit and hit no one. But imagine the version where the timing was different. Imagine astronauts on the surface of the moon or coasting through deep space, beyond the protection of Earth's magnetic field, when that storm arrived. The radiation dose to a man standing on the moon in an ordinary spacesuit could have reached levels far past what the human body can absorb. Estimates run to 10 times the radiation a person is supposed to receive in an entire lifetime, delivered in hours. Enough for acute radiation sickness, possibly enough to kill. The conclusion that scientists came to afterward is chilling in how plainly it's stated. The astronauts, they decided, might simply not have survived the trip. Think about that. We didn't avoid this disaster through clever engineering or early warning. We avoided it because the storm hit during a gap in the schedule. A few months in either direction, and Apollo could have become a fatal radiation event, playing out in real time, with the whole world watching, and no way to bring them home faster than the laws of physics allow. The sun didn't miss us. It just missed the people we'd put in its path. Number 5. The Tunguska Event. Go back to the morning of June 30th, 1908, to a stretch of Siberian forest along the Podkamennaya Tunguska River, so remote that almost no one lived there, which, as you'll see, is the only reason this is a curiosity in a textbook, and not one of the deadliest days in human history. A space rock, probably a stony asteroid somewhere around 50 to 60 meters wide, came in fast and exploded in the air about 5 to 10 kilometers above the ground. It never hit the surface. It didn't need to. The airburst released energy estimated at anywhere from 3 to 50 megatons of TNT, with many scientists landing around 15 megatons, roughly 1,000 Hiroshimas, going off all at once in the sky. The blast flattened the forest. Not a few trees, around 80 million of them, knocked flat across an area of more than 2,100 square kilometers. From the air, decades later, you could still see it. A vast circle of fallen trunks, all pointing outward, away from the center, like spokes on a wheel laid down by the hand of God. People hundreds of kilometers away were knocked off their feet. The sky over Europe glowed for nights afterward, bright enough to read a newspaper outdoors at midnight. And here's the unsettling part. There's no crater. There's no big chunk of space rock sitting in a museum. The thing detonated in mid-air and effectively vanished, leaving only the devastation as proof it was ever there. That's exactly what makes this class of objects so frightening. It doesn't leave a calling card you can study in advance. It just arrives and erases. Now do the arithmetic that every astronomer quietly does when they think about Tunguska. The Earth turns once a day. If that rock had arrived a few hours earlier or later, that same blast would have come down not over empty taiga, but over a city. Over St. Petersburg. Over London. Over somewhere with millions of people, and no idea what was about to happen. The largest impact event in recorded history missed wiping out a metropolis by a matter of hours. We didn't earn that. We just got the spin of the planet right that day. Number 4. Comet Shoemaker, Levy 9. Everything so far has been about what nearly hit us. This one is different. This is the time the universe gave us a live demonstration, on the planet next door, of exactly what we've been dodging. In 1993, 3 astronomers, Eugene Shoemaker, Carolyn Shoemaker, and David Levy, found a comet at Palomar Observatory that looked deeply wrong. Instead of one tidy point of light, it was a smeared string of them, like a squashed strand of pearls. They were looking at a comet that had already been destroyed. It had strayed too close to Jupiter the year before, and the giant planet's gravity had ripped it apart into more than 20 separate fragments, all now strung out in a line and looping around Jupiter on a doomed orbit. And we realized, doing the math, that those fragments were going to come back around and slam into Jupiter. We had a date. For the first time in human history, we knew a cosmic collision was coming, and we had time to point everything we owned at it. So we did. In July of 1994, over the course of about a week, from the 16th to the 22nd, those fragments rained into Jupiter, one after another, and every telescope on Earth was watching. The Hubble Space Telescope was watching. The Galileo spacecraft, out near Jupiter, was watching. We saw fireballs erupt above the clouds. We saw dark bruises bloom in the atmosphere, scars left by the impacts. And some of those scars were larger than the entire Earth. The combined energy of the impacts was estimated at the equivalent of hundreds of millions of nuclear weapons. More than every bomb humanity has ever built, many times over. Here's the thing that changes how you see the night sky. We watched it happen. We sat in our control rooms and our backyards, and we watched a world get hammered by debris from space, in real time, with our own instruments. And the only thing separating us from being the planet with the bruises was distance and luck. Jupiter, with its enormous gravity, may even act as a kind of shield for the inner solar system, hoovering up objects that might otherwise come our way. But that day, it wasn't a shield. It was a demonstration. A message, written in fire, across the face of another planet. And the message was simple. This is what happens. This is always what happens. Eventually, it's our turn. Number 3. Comet Swift-Tuttle. Every August, you can go outside on a warm night, lie back in the grass, and watch the Perseid meteor shower. Shooting stars, dozens an hour, streaking quietly across the sky. It's one of the gentlest, most romantic things the universe offers us. Couples watch it. Kids make wishes on it. Those shooting stars are debris, tiny grains of dust and ice burning up in our atmosphere, and they were all shed by a single object, the comet that is the parent of the Perseids. Its name is Swift-Tuttle, and Swift-Tuttle is not gentle at all. Its nucleus is about 26 kilometers across. Let that land for a second. The asteroid that ended the age of the dinosaurs, the one that carved out a crater hundreds of kilometers wide and darkened the whole planet, that one was around 10 to 15 kilometers across. Swift-Tuttle is bigger, considerably bigger, and it's on an orbit repeating roughly every 133 years. That brings it sweeping through the neighborhood of the Earth and the Moon. The minimum distance between its orbit and ours is unnervingly small, and it moves fast, around 60 kilometers per second relative to us. If it ever did strike, the impact would carry something like 27 times the energy of the dinosaur killer. That's not an extinction of one species. That's a reset of the biosphere. One astronomer, working through the orbital calculations, once called Swift-Tuttle the single most dangerous object known to humanity. For a while, there was genuine concern about a possible collision in the year 2126. Then, as always, more observations came in, the orbit was refined, and we found it's actually very stable. There's no real threat for the next 2,000 years. We can exhale. But here's the thing I can't quite shake. The next time you're watching the Perseids, that peaceful little drizzle of light, remember what you're actually looking at. You're watching the dust trail of a mountain bigger than the one that killed the dinosaurs. A mountain that crosses our path again and again on a clock measured in centuries. The beauty and the danger are the same object. We just happen to be alive during the part where it only sends its dust. Number 2. The Carrington Event. On the 1st of September, 1859, A British astronomer named Richard Carrington was sketching sunspots through his telescope when he saw something no one had ever recorded before. A sudden, brilliant flash of white light on the face of the sun. He was watching, live, the most powerful solar flare in recorded history. He didn't know it yet, but he was watching a disaster leave its starting line. The cloud of charged particles that the sun hurled out that day crossed the entire distance from the sun to the earth in about 17 hours. For comparison, that journey normally takes days. This thing was moving at around 2,300 kilometers per second. When it hit our magnetic field, the planet lit up. Auroras, the northern lights, are supposed to be a polar thing. You go to Norway or Alaska to see them. During the Carrington Event, they were seen near the equator. People in the Caribbean and in Mexico looked up at glowing curtains of red and green. In some places, the sky was so bright that birds woke up and started singing, fooled into thinking it was dawn. Gold miners in the Rocky Mountains reportedly got up and started cooking breakfast in the middle of the night. And then there was the technology. In 1859, humanity's most advanced electrical network was the telegraph, and the storm tore through it. Telegraph systems failed all over the world. Sparks leapt from the equipment. Operators were shocked. Paper caught fire in telegraph offices. Some operators disconnected their batteries entirely and found they could still send messages using nothing but the electricity the storm itself was pumping into the wires. Now here's the thing that turns this from a beautiful historical anecdote into the scariest item on this list. In 1859, that was the extent of the damage, because that was the extent of our electrical world. A few telegraph wires. Today, we have wrapped the entire planet in wire. Power grids, satellites, the internet, GPS, the transformers that feed electricity to entire cities. Every one of those systems is vulnerable to exactly the kind of storm Carrington watched begin. A direct hit on the scale of 1859 could knock out power grids across continents, not for hours, but potentially for months, because the giant transformers it would destroy take a long time to replace, and we don't keep many spares. And this isn't hypothetical. In 2012, a Carrington-class storm erupted from the sun and blasted straight across Earth's orbit. It missed us by about a week. The Earth simply wasn't standing in that spot yet. We didn't dodge it through any cleverness. We dodged it because of where we happened to be in our lap around the sun. The sun is still up there. It is still doing this. And one day, the timing won't be on our side. Number 1. We live inside the wreckage of dead stars. Everything on this list so far has been a near miss. Something that almost hit us. Or could one day. For the final entry, I want to tell you about a cosmic disaster that didn't almost happen. It happened. We just weren't around yet to see it. And we're still living inside the crater. Deep under the Pacific Ocean, locked into the crust of the seafloor, there's a faint dusting of a very strange metal. It's an isotope of iron called iron-60. And iron-60 is special because there's basically only one place in the universe that makes it. The core of an exploding star. A supernova. If you find iron-60 somewhere, you're not looking at ordinary iron. You're looking at fallout. And we find it everywhere. Scientists pulled up something like 120 samples from the floors of the Atlantic, the Pacific, and the Indian Oceans, and the radioactive fingerprint of supernova fallout is in all of them. It's even been found on the moon. The layers tell a story, and the story has dates. One pulse of this material rained down on Earth somewhere between 1.7 and 3.2 million years ago. There are signs of specific explosions about 2.3 million years ago, and again around 1.5 million years ago. Stop and sit with that. A couple of million years ago, which, on the cosmic clock, is essentially this morning. One or more stars exploded close enough to Earth that their radioactive guts drifted across space, and settled into our oceans like ash from a distant fire. Our early human ancestors were already walking the African plains when this happened. They may have looked up and seen a new, impossibly bright star burning in their sky, brighter than the moon, and had no way to know they were watching a sun die. But here's the part that rearranges your whole sense of where you live. Those explosions didn't just leave dust. They cleared a space. When astronomers map the gas around our solar system, they find that we are sitting inside an enormous, nearly empty cavity, a region of thin, hollowed-out space about 1,000 light-years across. They call it the local bubble. And when they ran the simulations to figure out what could carve a hole that big in the gas of the galaxy, the answer that came back matched the bubble perfectly. A chain of supernova. The same explosions that left their ash in our oceans also blew the bubble we live in. So this is the thing I want to leave you with. We tend to picture space as the safe, empty backdrop, and disasters as the rare visitors that come crashing into it. But it's the other way around. The emptiness itself is the aftermath. The quiet, dark, roomy patch of galaxy we call home is not pristine. It's a blast site. We are not waiting for the cosmic disaster to arrive. We are living, right now, inside the cooled-off wreckage of one that already came, breathing easy in the hollow that dying stars left behind, on a small wet rock that still carries their ashes at the bottom of its seas. Space is not a thing that happens to us. We are a thing that happened to space. And the only reason any of this feels calm is that we showed up after the explosion, in the brief, beautiful quiet between one catastrophe and the next. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.